Hello Year 10, going to start on chapter 13, factors, powers and roots. This is going to be for 13.1, which is all about factors. Quite a few definitions and terms that you've got to make sure you learn and remember. Key skill I would say is making a factor tree. So knowing your multiplication times tables will really help to do that. I will be giving you a few demonstrations and showing you examples. You just need to be working through 13.1s and then 13.1a doing the exam application questions. I will put this PowerPoint up in Moodle, so if it doesn't come out too clearly, don't worry, you'll be able to look at it in Moodle. So lots of definitions, as I say. A factor, hopefully you know what that is. A factor is a number that goes exactly into another with no remainder. So factors of 12, as you can see, they're all listed. Also good to remember that factors usually have a partner to create a factor pair. So 1 times 12 is 12, they're a factor pair. 2 times 6 is 12, so they're a factor pair. 3 times 4 is 12, and they make a factor pair as well. The only real exception to this is if you've got something like a square number, 16, 4 times 4 is 16, so it's just the same number multiplied by itself rather than a pair of two different numbers. Multiples are essentially the numbers that are multiplied up from the original. So 3, its multiples are the 3 times table, 3, 6, 9, 12, 15, 18, 21. And the better you are at times tables, the better you will do in your exam. Save you time and make sure you don't make silly errors. So maybe during lockdown, something else to do is to improve your times tables. Prime numbers, hopefully you remember those as well. They only have one factor pair. So 11 is a good example of a prime number. The only factors of 11 are 1 and itself 11. 1 times 11 is 11. There are no other numbers that go into 11 exactly. There is only one even number, which is prime, and that's 2, because the only factors of 2 are 1 and 2. Every other even number in the world, obviously 2 is a factor of it. 4, 8, 6, onwards, 2 always goes into it. So the only even prime number is the first even number, 2. So this is an example of what I mentioned, a factor tree. If you look at 120, it's been split into its two factors, 10 and 12. You then split 10 into its two factors, 5 and 2. And when we get to 5 and 2, they can't be split into anything else other than 1 and 5 for 5 and 1 and 2 for 2, because they are both prime numbers. So they're what we call the prime factors. We've got to the very bottom of that branch of the factor tree. If we look at 120, the prime factors of 120 are 5, 2, 3, 2 and 2. If you multiply those together, 5 times 2 is 10, times by 3 is 30, times by 2 on the other tree is 60, times by that other 2 gives you 120. So when you multiply all the prime factors together, you actually get back to the number. Similarly, if you look at 45, its prime factors go down to 5, 3 and 3. 5 times 3 is 15, 15 times the other 3 gives you that 45. Okay, we're going to use the factor trees and their prime factors to work out something called LCM, the lowest common multiple, and HCF, highest common factor. This is a process that I'm going to be demonstrating in a moment. So lowest common multiple, that is the lowest number, the smallest number that is a multiple of both of them. So it's common to both of them, the lowest common multiple. If you look at the answer there, we've got 360. That is the lowest number, the smallest number that 45 will multiply up to, and 120 will also multiply up to. Highest common factor, HCF, of 45 and and 120. You can see there the answer is 15, and that is the biggest number, which is a factor of both 45 and 120. So it's the highest common factor. It's a factor of both of them. Okay, so we're now going to go back to that last slide and look at how we actually work out how to do those. And if you look at another example, there's an example on page 258 of the actual textbook. So here we got what we call the prime factors of 120 and also 45. If we go back to the previous slide, you can see where I got those from the bottom of the factor tree. Also for interest, you can see that 5 times 2 times 3 times 2 times 2 can be written as 5 times 3 times by 2 to the power 3, because you've got 3 2's in there. 2 times 2 times 2, 2 to the power 3. And also we can see 45, which is 5 times 3 times 3, could be written as 5 times 3 squared. Don't need that for the piece of work we're doing at the moment, but it will come in useful later on. Okay, diagram at the bottom is called a Venn diagram, or you might know that as sets. And what I've done is I've put the factors of 45 in the 45 circle and the factors of 120 in the 120 circle. However, there are two numbers which exist in both of them, 5 and 3. If you go back up to those lists at the top, so 5 and 3 are common factors of 45 and 120, so they fit in the middle. They appear in what we call the intersection of those two circles. Okay, so to work out what the smallest number that is a multiple of both, the lowest common multiple, I have to multiply together all of the factors, but I don't repeat factors. So if you go back, I've got 3 times 5 times 3 times 2 times 2 times 2. So 5 and 3 happen in both of them in that intersection, but when you look at what I've done there for that multiplication, I've only used them once. So that gives me 360. If I use those common factors of 45 and 120 twice, I would obviously got a number 360 multiplied by 3 again, multiplied by 5 again. That would be much bigger, and it wouldn't have been the smallest common multiple, the lowest common multiple of 45 and 120. The highest common factor, to work out that, you just use the two numbers that are factors of both 45 and 120. So there are those two numbers in the middle, 5 and 3. So 15 is the biggest number, is a factor of both, so 15 is the highest common factor. Only numbers in the intersection. Hopefully you can see these in Caboodle. I'm going to just talk through a few of the early ones because they are reasonably simple, I think. If you look at 4a, 3 squared, 3 times 3 is 9, times by 5 squared, 5 times square 5 is 25. So 9 times 25 is 175. If you look at D, you've got 2 squared, or you might consider that 2 to the power 2, multiplied by 3, multiplied by 5 squared, or 5 to the power 2. So 2 squared, to start with, is 4, times by 3 gives me 12, and then times that by 5 squared, which is 25. 12 times 25, I make that to be 300. So now we're looking at that key skill I mentioned of factor trees. 36, split it up into a factor tree to get to the very bottom and its prime factors. So 36, you can split that in a few ways, but I'm going to split it up into 6 times 6. You could have split it into 2 times 18. So we'll show both of these just to prove they do come out to be the same thing. Over on this one, 6 would split into 3 times 2. And again, 6 would split into 3 times 2. Now each of these is prime, can't split up, so you can just put a line under them, or what we saw earlier, they put a circle around them, whichever you prefer, just so you know got to the bottom. 2, we know that's prime, so we stop there. 18 would split into 9 and 2. 9 would split into 3 and 3. So again, we can see we've got the same prime factors. 2, 2, 3 and 3. Any way we do it, that's where we get it. So again, you can write that as 2 times 2 times 3 times 3, or you can write it as 2 squared times by 3 squared. Either way works. Moving on to 11a, I've done the factor trees for 180 and 420 just to save a bit of time, and you can see the prime factors of 180 are 2, 2, 5, 3 and 3. Prime factors of 420 are 3, 2, 2, 7 and 5. So here I've drawn a diagram for that Venn diagram, sets, if we might also know them. And what I'm going to put in is things that are common factors of 420 and 180. So the easiest way I find is just to look at this diagram. I've got a 3 here and also a 3 here. So I could put a 3 in this intersection. Anything else happens in both. I've got a 2 here and a 2 here. So I can put 2 in there. Anything else? Well, there's that 5 there and also a 5 there. So that happens in both, can go in the intersection. Anything else? I can also see a 2 here and a 2 here. So that goes in there. So I've got 2 2's in here, but it has matched up on each one. Only things left in this one, I've got that 7. So 7 goes in there. Only thing left on this side, I've got that 3. So that goes in there. So the lowest common multiple is all the numbers in the Venn diagram. But remember, these numbers happen twice. They happen in this one and this one, but I'm only worried about them once because they happen once in the Venn diagram. So the lowest common multiple is going to be 3 times by 3 times by 2 times by 5 times by 2 times by 7. Hopefully I can do this in my head. 3 3s are 9, times 2 is 18, 18 times 5 is 90, 90 times 2 is 180, 180 times 7, well, 7 times 80 is 560, 7 times 100 is 700, so if I add those up I'm going to get 1260, but you can check that in your calculators if you want. And then I'm now going to look at the highest common factor. Hopefully remember the highest common factor was only the numbers that happen in the intersection, so it's these. So this time it's 3 times 2 times 5 times 2. So 3 2's are 6, times by 5 is 30, times by 2 is 60. So the highest common factor, the biggest number that goes into both, is 60, and the lowest common multiple, the smallest number that both 180 and 420 multiply up to, is 1260. Okay, that's me doing the examples. You can now practice those skills yourselves. Make sure you mark your work from the answers in the back and go back and check what you're not doing. But probably one of the things many of you will need to do is to practice your actual multiplication timetables, get them as quick as possible. Good luck. I'll be coming back with 13.2, hopefully by the end of the day.